Cisco Secure Firewall, Netops and Secops focus. This is demo time. Couple things to call out right away. Some highlights in Cisco Secure Firewall 7.2. First off is umbrella integration. We now have two forms of DNS layer protection. The first layer is local DNS policy powered by Talos Threat Intelligence. This is the early stuff. Get out of my way. Then we've got umbrella that allows us to centrally build policy for all assets, including firepower, and enforce those policies for both allow and blocking outcomes. Then we get encrypted visibility engine. This is advanced security intelligence. So we're providing high confident assignments of processes to client applications. So this improves OS detection, support for protocols like QUIC, and TLS cert pinning where you can't do TLS-based decrypt. Examples of these could be TrickBot, Emotet, and Dridex, all of which have used other forms to evade decryption-based policy. Then we get into TLS decryption. So this is person in the middle, the ability to use Snort version 3 and some machine learning capabilities of the platform to identify threats in TLS 1.3 based encryptions. Access control policy lock, the ability to lock the policy to ensure nobody else is able to edit that policy before you push those changes out. VPN and certificate and SAML authentication. It's time to level up both machine and user-based certificate before SAML-based authentication and authorization. And then finally, elephant flow handling. These are huge flows. They're enormous. And what we want to do is make sure that we're identifying those so they don't impact the Snort process. So CPU hogging, packet drops, and so on. Once we identify them, we end up moving them into a fast path mechanism to ensure that the platform maintains highest level of security, efficacy, and performance. All right, we're in the dashboard. The first thing that we're going to do is we're going to change this to dusk mode. To me, it just looks better. All right, let's get started. Now, we're going to focus on NetOps first. Things that are valuable to the network operator or administrator managing firepower. Now, one of the things that provides a ton of value is the ability to reuse objects. And you can see we've got a ton of them here. Network, policy list, PKI, you got VLAN tag, VPN, URL. There's a ton here. And it's very easy to create an object. You come in, create an object, give it a name, a description, and then determine what it is that you want it to be. Is it a host, so /32, a range, a network, an entire segment, or an FQDN? Now, in this case, what we're going to do is create internetbadguys.com. We'll go ahead and save that out. And now we have a object that's fully qualified domain name, and I can use those in policy such as NAT. Now we can very quickly search and parse. Now, objects aren't a big deal, especially in network objects. Lots of different platforms have those. Now, we can look at unused objects and very quickly find what we're looking for, but here's some interesting elements. Now we have application filters. Not only can we create our own application signatures for custom applications using OpenAppID, but we can build filters and collect them into a filter that allows us to perhaps identify a core application within our organization that has multiple different application signatures assigned to it. Now, as an example, I can look at things like human resources, instant messaging, but again, I can come in and create my own. So my apps, and then I would add the specific signatures that I've developed for the platform, not having to go to Cisco to get these created. I mean, create them on my own. The other one is external attributes, dynamic objects. So the ability to take things like AWS tags or Azure or something from Cisco Secure Workload and feed those dynamic labels into the platform to build policy automatically so I don't have to deal with this day in and day out operationally. So what this means is that as a new workload comes up with a new IP, because it's based on tag, I have policy that feeds that into the platform, and automatically that asset is allowed access based on the control that's implemented. In fact, I don't even have to push policy. Then we get a bunch of PKI certs and internal CAs and things like that that we can integrate into the platform. Now I've jumped over to access policy. I'm going to show you this from scratch here, but I'm going to create a policy for the branch. It's going to be pretty simple, but you get the idea. Give it a name. I'm going to block all action on default, so a real firewall, not an intrusion prevention platform, although I could be a dedicated platform here. I go ahead and create that. I've got no rules here other than the default block all traffic at the bottom. Now, the first thing I'm going to do is I'm going to turn on some security intelligence. Get rid of that noise earlier on. I do not want to leverage the platform to determine something is bad by analyzing the packet when I can just drop it out of the gate. So here I'm going to collect all of the network objects that identify as bad, and I'm going to add those to the block list, and you can see the list here. I can scroll down for suspicious spyware. And I can also go over to URLs. So again, I'll go through here and I'll collect all of the URLs and I'll add that to the block list as well. Now I've got network objects or based on IP as well as based on URL. Now I could add a DNS layer policy here as well as the umbrella DNS integration to ensure policies enforced consistently across my organization when it comes to DNS-based policy. Now I'll go ahead to advanced. There's a couple things here that are worth calling out. One is elephant flow settings. You can see by default it's enabled. I have the ability to enable remediation. In this case, I'm just going to leave the defaults as enabled, but that's elephant flows, so flows that are large that could impact the performance of the platform, like backups. You shouldn't be inspecting backups. TLS server identity discovery. Now this is a good one. This is like encrypted visibility engine in the sense that I don't have to decrypt the payload in order to determine something might be happening. So we create a side channel from TLS 1.3 to 1.2, analyze it, and determine if it's bad. If it's bad, we'll drop it. If not, we'll allow it to move forward based on policy. And that could mean decrypt as well. Now, encrypted visibility engine, this is what we talked about earlier at the beginning. The ability to use that analytics engine to determine things are bad without having to decrypt the payload. And this helps with things like TLS cert pinning as well as QUIC protocols. And it fast pass thing. It doesn't have to be decrypted in order to determine it's bad. Now I'm back in the rules here, and I'm going to create a couple simple rules. One is block bad geos. So I'll select a couple of geos of interest. You know, I can do it based on continent. I could also do it based on country. And again, I'll pick a couple here that are pretty standard in North America when it comes to blocking. So we've got China, maybe North Korea. What do we got here? You can see Thailand, Vietnam. We'll go ahead and maybe go to Europe and we'll grab Russia, and maybe what we'll do is we'll grab one more, but you get the idea here. Let's grab Belarus. All right. And for this particular policy, we're going to do a block. We're not going to send a reset. We're just going to actually block it. We're going to make it into mandatory. So we'll insert it into mandatory. And inspection, we're going to log at beginning of connection. There is no end of connection because we block it right out of the gate. So that's going to be our top policy. Very quick, easy. We're going to go through security intelligence, get rid of the noise. And then the next thing is going to be the geos. Now I've transitioned into the new policy UI, and you can see it's a little bit different. Everything's here all in one place. So this one we're going to do block URL bad, and this is just an example. We'll add some sources here. Again, we can go into inside, outside for zones. We could be really granular by adding network objects. Now, when you're building policy, you don't want to add every single attribute to truly define the flow. All you need is enough attributes to make it unique enough to get it to catch and apply policy. Adding more is just burdening the platform and decreasing performance. Now, in this case, we're going to do it inside zone 2, HTTP and HTTPS is the destination. And we could look at application here as well instead of using port. So we can do it based on application identifiers. And here I'm searching for Tor, BitTorrent, and maybe I want to block BitTorrent. Now, I might get rid of the protocol or port instead. Now, identity, if I had identity integrated in the platform, I could do it based on user as well. And then I could create a URL. Maybe I'm being very, very specific here. Discoveredbad.com, and the URL is discoveredbad.com. So we want to capture and catch everything that's under that. And from here, we could see our object that we created, and we can very quickly search for it as well. So go ahead and add that URL. Dynamic objects, that's what I mentioned around grabbing tags from Azure or AWS or Cisco Secure Workload. This is going to be a block policy. We're going to log at beginning of connection. So we've got our two block policies. One is bad geo, the other one's a bad URL. We'll go ahead and add a rule here. And this one's going to be an inside to outside and allow policy. So we're going to allow this rule inside and outside. So the first thing we're going to do is grab our zones inside to outside. Now we might grab a couple of objects here on the inside. We could grab inside network if it housed inside zone 1 and 2. I noticed that maybe this object here needs to be changed. And so I can very quickly come in here and say, you know what, that's inside zone 2. Let me make that change. I don't have to go all the way back to objects to do or drive that outcome. So this is efficient as an operator. Now port, again, applications here. I could select something like web browsing and maybe add it all over as an entire group, or I could be very specific here. Maybe there's certain browsers that I don't support in the organization, and to reduce risk, I may only allow the ones that seem to serve the organization best. And let's see, Safari. What else we got here? Maybe Chrome. And so now we've got the objects that we are interested in. We've got 4 of them, 4 applications, and that's inside outside. Now we could also add IPS and malware inspection to this rule based on any security mandates within the organization. Now we'll go ahead and save that policy out. We'll go ahead and we can assign this to one or many devices if we choose to do so, which makes it pretty easy operationally. You can create one policy. You can also modify that policy and apply it to different platforms. Now, a couple of things that we probably like to do, simplifying our role as NetOps, is creating a policy for the health of the device and maybe apply that policy to one or more devices. So think of this as more of an advanced object that collects all of the health elements of a platform, and you can assign it to one or more assets. So health modules, you can see appliance hardware, any alarms, CPU, you can see it's disabled here. I'm going to turn this on. The thresholds look good to me, 80%. Data plane statistics, database, health monitoring, high availability. Runtime intervals, I can tweak that if I want to. I can save this out. And the beauty of this is I can apply this to one or more Firepower devices or Cisco Secure Firewall devices. So now that I have my health policy, I may have pushed that out. I've created a very quick access control policy. I might look at integrations. I might want to also create a platform policy that's consistent across the organization. Again, I could create one or more of these platform-based policies and push them out to one or more Firepower devices or Cisco Secure Firewall. So in this case, we're going to call this branch device. Maybe there's something specific for branches, and so there's some subtle nuance here that we're going to capture. Unauthorized access for the banner. We might enable DNS resolution on the platform. And again, as we pivot into the platform and we need to create objects, we don't need to move into objects. We can actually drive that outcome from the interface from which we're working in. So in this case, my DNS, and we'll go ahead and add our DNS server, and we'll go ahead and save that out. There's our group. We can make it as default, and we can go ahead and hit OK. Now we can also say what interface we're going to use DNS on. In this case, it's going to be inside external authentication. So if we want to integrate that into Active Directory and do role-based control, we can do so. Enable HTTP server maybe, or SSH, ICMP access, depending on the needs to the organization. Time synchronization, time zone. So you get the point here. I can create a centralized platform policy and apply it to one or more devices. So go ahead and save that out. The goal here is create once and use many. Now, we might need an app policy. Branch offices, likely we do. So let's go ahead and create a branch NAT policy. Again, this is going to be pretty simple policy here. It's going to be a dynamic policy, manual NAT, inside, outside. The translation is going to be inside network to the destination interface IP. Go ahead and hit OK. And again, we can save this out and we can apply it to one or more devices. Now, real quick, I'm going to show you remote access in the sense that it allows us to do a wizard-based deployment. So it's going to walk us through step by step on the configuration of building out policy assignment, connection profile, AnyConnect, the certificate and access, and then the summary, and we're done. Now let's just jump back to device management in the interest of time here. I've got multiple domains here, so I'm going to switch the domain. And a domain is just like a container where I can manage multiple different firepower devices or Cisco Secure Firewall and also use role-based access control. Now we're in the device. This is a nice summary of the licenses, the system, management IP, any advanced settings enabled, applied policies, the health policy that's assigned. It lets us know what inspection engine we're using, in this case, Snort version 3. We can jump into routing where we get all the standard stuff that you would expect for any firewall in the industry, but including policy-based routing where I could make decisions based on applications and the quality of that connection and maybe load balance that over multiple connections or fail over in the case of services being degraded. We also have the ability to leverage virtual routing within the platform itself. So multiple different ways to perform routing, whether we want to contain it and isolate it because we have IP overlap, or we want some advanced capabilities like policy-based routing. Interfaces, this is where I can come in and very quickly configure my interfaces. Inline sets, if I was an intrusion prevention platform, I might want an inline set to be inserted within the infrastructure. I've got DHCP, obviously, and VTEP support as well. All right, let's go back to device management. And here's some nice tools that we have available. Packet tracer, packet capture, we can revert and upgrade, we can do health monitoring, or pull the troubleshooting files. Now let's jump into packet tracer. Now, Packet Tracer allows us to simulate policy, which is pretty neat. I can actually go through and say, all right, let TCP/IP, IPv4, this is the host. I could also use a PCAP, but this is the host, maybe the source port. Well, this is going to be upper layer port, so 3245. In the outside interface, destination type, 8.8.8. based on IPv4 and maybe HTTP as an example. Go ahead and trace that. It gives us a very colorful output of that policy that's simulated through the platform itself. It lets us know access lists, whether or not it was allowed or dropped. It looks at the route lookup, object group search. Here we can see it, in fact, was dropped based on this access list. And the final result, in fact, was dropped. And it'll include things like snort, if snort's involved here. It's not because of the way I've created this trace, but you get the idea. And again, I can upload a PCAP file into the platform. So that's one way. The other way is do a packet capture with the trace capabilities enabled. So very quickly, I can come in here and add a capture, give it a name. Pick your capture interface, in this case inside, And we're going to do any. We're just going to capture everything here. Not a big deal. We're just giving you an idea that we can be very granular, but we can also see everything. And in this case, it goes phase 1, 2, 3, 4 is snort. It says allowed, and it continues to go through based on all the packets that we've captured over that period of time. In fact, we captured 124. Now, if you're looking for something specifically, obviously you would use the tool's ability to filter based on multiple different attributes. We can save this off. In this case, we're just going to pause. And from here, let's go to Threat Defense CLI. So again, instead of having to run into the device, SSH to run a command, you can come in here and run a show command on the platform itself. There's two ways to drive an outcome on the platform. One is through the Firewall Management Center, which we're doing here. The other is through API. Now let's go ahead and look at scheduling. Another thing operationally that we'll want to do is make sure that we're updating the platform regularly, doing backups. There might be other things like generate reports, install the latest updates, etc. So here, what I'm going to do is just quickly create a job to download the latest updates, make it recurring. I can do it hours, days, weeks, or months. Pick my date of start. And we're going to repeat this every month. You know what? Every week. And let's go ahead and pick a time. 11 p.m. sounds good. And maybe we'll do this Friday. Remember, this is only downloading, so there's no installation done here. And now you might pick a time as well to schedule an installation. And we're going to pull both software and vulnerability updates. We could email this out, and we'll save it. And now you can see on the 29th here, today is the 18th in red. And if we go over to the right on the 29th, we can see there's our download updates. Now I'm in unified events. Now this is pretty neat. I can see everything, connection events, intrusion events, malware events, all in one place. And very quickly, I'm going to parse this data to malware events. Now this is more SecOps, although we know that most NetOps wear the SecOps hat. But this is where I can do deep analysis. So very quickly, I see malware in the organization. I could pivot and look into it. Here, I'm just looking at all connection events, and I see an intrusion. So if I wanted to very quickly filter based on intrusion, I just have to click it. I can do it based on IP and a bunch of other filters as well. I just start typing in. Now I can see the intrusion, the date, time. I can see the message, the snort ID signature, the policy that's assigned to it. But let's go ahead and jump right into intrusion events. Now we could get here multiple different ways, but look at, in this case, we're going to look at every single IPS intrusion event. And we're going to go ahead and view one of them. So here's one. We can see very quickly the source and the source IP, but what's really neat is we get a host profile. We can see the current user, last seen, host type, MAC addresses. I can see any indications of compromise. I can see what operating system that the asset is assigned to or potentially assigned to, in this case, Windows. I see host protocols, vulnerabilities. Now this is key. I can actually learn a little bit about the vulnerability as well by pivoting into the platform. Now we do this passively, but you could integrate the vulnerability data using a real-time vulnerability scanner. Now, I'm in packets, and I can drill into the payload itself. So one thing that's unique to Cisco Secure Firewall, or Firepower, is our ability to capture packets during an event. This isn't something you need to turn on. Performance is considered when sizing out the platform that this is going to be the default behavior. And why this is important is that a lot of times these are one-time attacks, and I want the packet. And a lot of times what you have to do is go into your firewall after you see some activity, go turn on packet capture, then wait for something, and it never happens. I can also download that packet. So not only can I view it in the browser, I can also look at it and view it in my favorite tool, like Wireshark. Now I'm in malware events. Now there's lots of things in the platform here when it comes to analysis of malware. We have the ability to sandbox. It's native to the platform itself, and it'll give us a dynamic analysis summary of the file. So again, this might be more of a SecOps focused area of the platform, but certainly Netops would have a lot of interest here as well. And here's the report itself: behavioral indicators, the TCP/IP, the processes, the artifacts, any registry entries. Again, what's typical in most sandboxed environments. Now, there's some unique stuff within Cisco's ability to do it from the outside looking in, so it can't be detected by the adversary, or very difficult to do so. But it's pretty neat. Now we can jump into the dashboard. You can customize these any way you want. You can add widgets very quickly by coming in here and making some modifications to the widgets itself. You can change the colors, move them around. You can look at it from a threat perspective. Very quickly, I can see indicators by compromise by the host itself. And this is that host profile again. And I get all that detail with those 3 events that are triggered on that particular asset. I can also see it by user. Now, April seems to be busy here with 5 indicators of compromise. Intrusion events. I can focus on my view in regards to just intrusions themselves. You've got status, some geolocation, so intrusion events by source country, and maybe I want to block a country. Now, what's nice about this is the dashboards are great, but I can pivot into a report and generate or build a report off of those dashboards. I can fully customize this as well. So here I very quickly pulled off a report. Let's go ahead from the dashboard, right, into the report. It built this all out for me. I didn't have to do anything. Now, I could have changed some things. And let's go ahead and open that report. Now, I might notice some things I need to change, and I have the power to do so. But there's also 3 other reports: advanced malware, attack, and network risk reports. These are kind of executive style reports that are built into the platform. So I can run this over the last week. I can give the company name, the author, the contact, and I can go ahead and generate this report. Now let's go ahead and look at that attack report. Now this is focused on attacks themselves. It shows me total attacks, relevant attacks, assessment results. It gives me a cost breakdown as well, which is really neat because I can look at the number of events that's taking place and our ability to understand the true impact of those threats. Now, let's get into some fun stuff. The power of open source. Breach attack simulation, attack IQ, Cisco Secure Firewall, CNC Cozy Bears, CNC web communication. We're going to be in audit mode and we're going to have a little bit of fun in this one. Let's get started. All right, we're in attack IQ. Let's go to assessments. And here we're going to create a new assessment, create custom. And let's go ahead and add a scenario here. Add scenarios and let's search CNC. And let's look for Cozy Bear. What do we got here? There's Cozy Bear CNC web communication. That looks pretty good. After malware is dropped, it will run or showing a video to trick users while in the background it installs a botnet. This is the path that it's looking for specifically. Let's go ahead and turn on any Cozy signatures that we might have, or Cozy Bear signatures that we might have within Cisco Secure Firewall. So let's go ahead and do that first. We'll go ahead and search for Cozy. What do we got? And we could look for that path and do some other stuff, but I know that we're not going to detect this. That's the point of this exercise. And so we can look here. We've got malware, CNC, Trojan, Cozy Bear, outbound connections established, and it's looking for content galleria index.php. So that's not going to catch it, but we're going to turn this one and the other one on as well. And these are both pretty much the same. I don't see any difference here. So yeah, so I'm just checking here. This looks good. Okay, Let's go ahead and block both of these. And you can see we can alert, rewrite. We have the ability to drop, reject. Lots of options here on how we might want to action this particular signature that gets fired. All right, so that's enabled. That looks pretty good. Let's just jump back in. Let's make sure we've got it enabled, that it actually saved. This is just doing some due diligence here. Let's go back into rule overrides, and we can see there's the two signatures enabled. If we search, there's not going to be any additional Cozy Bear options here. Okay, good. We'll go ahead and deploy this. I fast-tracked the deployment. We don't need to necessarily see that. But now that we've got the signatures in place, we can go ahead and run our scenario in Attack IQ and see what happens. What I'm going to tell you is that there is not a signature enabled that's going to detect this. We're going to get to that piece in a minute, but let's go ahead and run our tests and validate that it does fail, meaning that we're not able to detect or prevent this particular scenario. Let's grab that name. We're going to use that as a descriptor. In our titles, we'll review and add. Let's add scenario. Done. Go ahead and rename the test. And let's go ahead and do the same here for the entire set of scenarios because we're only doing one here. So we'll use the same. We'll go CNC. We'll call this audit. Let's just fix the audit. Let's get rid of that. Audit and the name, and we'll go ahead and check that and close this out. We'll add our endpoint. Remember, the endpoint's on the inside of Cisco Secure Firewall that has the Attack IQ agent that's going to make the request outbound. We'll go ahead and hit run now. There's no integrations. We could have integrated Cisco Secure Firewall into Attack IQ as well, so the reporting goes directly into Attack IQ, but I did not do that for this scenario. Let's go ahead and do go live. And I can already see web application flash video. I'm pretty sure that's it. This should stop in a sec. And it shows 100% not validated. Okay, let's cancel this out. Go ahead and jump back into the test itself, and let's just have a look here. And connection was successful. And if we look here, we've got a code 200 that we know is acceptable. If we look at observable details, we can see that request path there. So we know that we weren't able to detect this particular scenario. Now, I did grab the request path because we're going to do some creation of signatures. This time, though, we're going to use ChatGPT. I thought, why not? And here we're asking, now you have to play with this a little bit, but create a Snort version 3 signature in the following order in one line. Alert TCP home network to external network using HTTP ports with a message of malware, CNC, Cozy Bear, potential web script, security vulnerability detected, with flow to server established, and HTTP URI has no value, content without brackets. There's the content that we're looking for. Metadata, impact flag red, service type is HTTP, class type is Trojan activity, and we give it a SID and GID. We ask the question, can you do it? ChatGPT. It's not perfect, but it's pretty darn close. So imagine if you create these, even if you don't know how to use or create Snort signatures, you can come in here now and say, listen, explain each line. I'm trying to learn here as well. And it breaks it down. Alert TCP home network to external network using HTTP ports, the message flag, the flow to server established, meaning it needs to be established connection. What content am I looking for? What does that actually do? Fast pattern, the class type, SID, GID, and so on. There's the summary. I'm learning a little bit more of this. And again, you can play with this. You can take this and try to import it as it is, and it's probably going to fail. Well, I know it's going to fail. There's a couple things that we need to change here. We need to add HTTP URI just before content here. HTTP _URI, and we'll add the semicolon, space, then content. For whatever reason it missed it, and you could tweak and play with it to get it to happen. And the other thing is that we need a comma here between the content and fast pattern. That was not there, and fast pattern in no case. It needs to be comma, not semicolon. I made the adjustments, saved the file out. Let's go ahead and import it and see what happens. But you can see how powerful we can augment our own capabilities with things like ChatGPT. Pretty cool. All right, let's go ahead and import this and hopefully be successful. I create a rule group called Cozy Bear, and we'll go ahead and import this. Let's just check that it's here. It is. Let's set it to block. And we'll go to policies, intrusion. We'll go to snort version 3. We're just triple checking that it is in fact enabled in our policy itself. And we can see now here's that new signature that we just created to address a gap that we may have identified in our testing. Go ahead and deploy this. And again, I fast-tracked this. You don't need to watch a minute and a half of deployment. Now it's deployed. We can now rerun our tests again. So let's go ahead and do that. We'll run our test. Run now. Jump back in. Let's go to analysis, unified events. And go live, and we should see something shortly here. Come on. Did we catch it? And if we catch it, we're in audit mode. We would have blocked it, and we did catch it. There we go. We didn't see this last time. And now we see we've got our reason. We would have blocked it. The impact score, the intrusion message, the snort ID, the classification is Trojan, and then all the specifics around policy and all the good stuff, right? And there's that URI that we were looking for. We use ChatGPT to augment our capabilities to build out the signatures without having to call anybody. We were able to do this on our own. If we drill into this specific event, we can see everything around the event itself, right? The reason, the source IP. We can look at the host profile, egress interface, ingress interface, the domain, the device, the intrusion policy that was hit, the access policy, all the good pieces of data that we would be interested in if we were analyzing this. And we can jump right into this particular packet, view the packet in the web GUI on an iPad, even on your iPhone, if you had a secure connection into the platform, and you're out with your family and you've got this incident that triggered, you're going to be able to see that. Or you can download it and open it up in a tool like Wireshark. And again, it just breaks it all down. You can look at and review the packet itself, all the details around it. And that's pretty much it. And again, this is done natively within the platform. I'm able not only to create signatures using a standard-based rules language, but I'm also able to come in and see that packet. I don't have to turn this on. It's very important. A lot of these attacks are one-time drive-by attacks, right? They get in, they do their thing, and it's over. And then you say, well, something's happening. I'm going to turn on packet capture. Too late, right? So sorry, it's over. Let's go ahead and drill into this. Let's look at this particular event. Again, it says not prevented. And the reason why it says not prevented is because we're in audit mode. But we already know Cisco Secure Firewall has already told us, hey, you're in audit mode. We would have blocked this if you were in preventative mode. So let's go ahead and make that note here. Next Gen Firewall running Firepower. Next Gen Firewall running Firepower Threat Defense has a custom rule that can prevent this connection. And you can put in here, ran an IDS and move into prevention mode, make some additional comments.